Okay, good morning everybody. Welcome to the training. Today our training is about gas turbine machinery control. So before we start the training, I would like your cooperation to put down your name, your designation, and your signature on the attendance list. You can pass it around. Okay, we have got your COVID-19. Okay, steady. Alright. Thank you for signing up with the gas turbine machinery control training. I will be your trainer for today. First of all, before we start, probably we will start off with some ice breaking. Maybe I need each and every one of you to introduce yourself with the following information. Just tell us your name, years of experience that you have in rotating. What do you expect from this training? And lastly, some interesting fact about yourself. So I'll start with myself first. Okay, morning again. My name is Feng. You can call me CF. I will be your trainer for today. I'm originated from Sungai Petani, Kedah. I've worked with PETRONAS for 15 years. I started off as a project operation readiness engineer in Sarawak, doing mainly brownfield modification and also greenfield commissioning. I think the truck 2031, part of the commissioning team. So after that, I moved in 2014. I transitioned myself into operation management role. So I assumed the maintenance supervisor role in NC3 for about 3 years. So starting with even attached myself to the Pasir Gudang MFC yard for a year before I moved to habitate the LQ and also commission the NC3. Then after that, 2017, I was given a chance to make a very bold switch from operation into rotating. Ever since that, my diversification worked so well that I remain in rotating from 2017 even until now as a rotating machinery manager. So these are some of the certifications that I've obtained throughout the years of my career. So I have required analysis MA2 certification, vibration CAT 2, ICE engineering grade 2, and also BTEC PSMS, that is for the upstream operation management. So maybe we can start with maybe Ben. Okay, yeah.
My name is Feng. I am from Belagan, Sarawak. My experience with gas turbine, I don't really have experience because my location that I'm taking care of, I don't have that equipment. So my expectation from this training is that I love to learn really basic first and how I can apply in my future field that I will be taking care of. And interesting fact about me, I love hiking and I love nature.
So where do you normally hike?
Previously, last few days, I went to Rinjani Mountain.
Where is it?
It's in Lombok, Indonesia.
Wow!
Yeah.
You just came back. You just came back from Lombok. Okay,
Yeah.
interesting. Maybe you can share a little bit more some of the experience during break time.
Yeah.
Okay, thank you, Penny.
Okay, so my name is Johnson Pao. Years of experience as a rotating engineer is only 3 months because as I just entered this department, and the expectation from this training is to learn more and know more about GT machinery and its control from our trainer CF. And a hobby about me is that, well, it's kind of obvious that I like to go to the gym and like to work out. Yeah.
Okay. Okay, yeah, I can see that you're. Let's go. Okay, maybe next.
Okay, why I don't know. Okay, my name is Mama Indra. Years of experience with rotating, basically with Carigali is almost 2 years. Before that, with tractors is almost 4 years. Then for expectation from this training is I want to equip myself with the knowledge, especially for the machinery control close to GP. And also my hobby currently, I go to gym with Pao. So we can see later on 3 months I will come. Thank you.
Okay, thank you, Indra.
Alright, good morning, Chef. My name is Gloria Lane. So I come from Kuching, Sarawak. And then years of experience, this will be entering my 4th year in rotating. And the expectation from this training is I want to enhance my knowledge in GP and control, especially having one GTC, so the rest of the GTC have to keep myself improve in technical knowledge. So my hobby for now, I have a new one, playing soccer, and hope to keep myself calm by playing soccer.
Sounds like you're under a lot of stress. So we pick up a new hobby, I guess. Thank you, Gloria.
Hello, my name is Efi. I joined marketing last January, so coming to 6 months. I come from Bintulu, so expression from this training, so I accept a better understanding of GTD control, so that I able to apply my knowledge to support safe available equipment safely in debtors.
Your hobby?
Hobby camping.
Camping.
Yeah.
You doing camping or you doing glamping? I think for me I prefer glamping. Okay, thank you, Efi. Okay.
Hello, my name is Shukri from SK Design. I've been with PETRONAS years of experience, 5 years lah.
Okay.
And expectation from this training, I just want to learn and refresh some of the from my past experience. I don't really have any fixed hobby. I would like to
What's your current hobby?
YouTube.
YouTube. When you making the content or you
No, I'm watching.
binge watching?
Yeah.
Okay, cool. Okay, thank you, Mr. Shukri. So I think we're done with the ice breaking. Just to gauge on everybody's years of experience. So if you have any questions, you can stop me and ask at any point of time. If I can answer on the spot, I will answer on the spot. Otherwise, if I cannot, I will put down the question bank in front of the whiteboard, and we will address the question accordingly at the end of the session or during break, during end of the module. So just if you have something in your mind, if you want to share some of your side punya experience or get some questions to be answered, then just stop me. You can stop me anytime. Oh, ada new participant.
Hi.
Okay, boleh tak introduce yourself?
Okay, my name is Feng from SKGS. So,
Years of experience.
I've been with PETRONAS for 9 years. Should be this year lah. And then for this training thing, I just want to assess the trainer. No lah. Just like, sorry. No, I just want to join this training lah.
Okay.
Probably I can gain something from it lah. And then my hobby is that
Anything interesting things about you?
I just love idol. That's it. Thank you.
Thank you, Apik.
Alright.
Okay, let's move on. Okay, we'll start off with a pre-test. So I'll pass on to you, each and every one of you, one of the pre-tests. Close to the back. It's a 10 question. You take your time to answer, probably about 15 minutes, 10 to 15 minutes. That's good. Once you're done, you just pass it back to me.
Right here.
Put your name down, by the way. You can even choose to skip the question if you are not sure, if you don't want to guess, because it's just to teach your understanding.
Excuse me, Mr. Indra.
Yes. Thank you, Mr. Feng.
All done?
Yes.
Done for that? Okay, boleh tak? You pass your pre-test to me. Okay. Thank you.
Mr. Feng?
Okay. How do you find the pre-test? Easy, medium, or is tougher than what you expected? Okay.
The first page easy.
First page easy.
Come
Second
to
page
next page.
exponentially harder.
Oh, yes.
Okay. So I hope that when we gone through this course, then you will be able to find the answers of the pre-test that we have gone through just now. That's a big class. So we're done with the pre-test. Let's move on. Our next will be the learning. Want to talk about the learning outcome. So after we have completed this program, you should be able to explain and differentiate the concept of machinery's monitoring, control, and protection. Second, describe the operating principle, major components, and subsystem of a gas turbine. The third one is explain the startup policy and also the startup sequence for a gas turbine. And last but not least, understand the protection system that's available on the gas turbine. This will be my presentation outline. It's split into 3 modules. First module, we will cover the introduction to machinery monitoring, control, and protection. Second module will be gas turbine components and also their auxiliary system. And the third module and also the last module will be the gas turbine control and protection system. So far, any question before I move on? Okay. Let's go into the first module. Introduction to machinery monitoring, control, and protection. So by looking at this name, you already know there's 3 things that we need to cover. First thing will be monitoring, second thing is control, and third thing is protection. Okay, I want to talk about control loop basic first. So when we talk about machinery control, there is always a loop that creates a feedback that gives you instruction, data, and also decision. So we'll start off with a sensor. In the control loop, you will see the first thing you will see is a sensor. So what is a sensor? Sensor is a device that measures or produces an output in response to a specific measurement. So anybody have any idea what constitutes as a sensor? What is considered as a sensor? Example, in your loop on, what can you see as a sensor? Switch is a not exactly. Normally switch we are called a finite element. So your sensor will be example. I'll give you a very simple example. Your loop oil pressure, data pressure transmitter. That is your sensor. That gives the signal. After that, it will go into your logic solver. Second item that you need to know in the control loop is your logic solver, which is most of the time your PLC. That is normally located in your PCB, normally at the second slot of the chassis. When the sensor produces some output, that signal in any form, it can go in any form, it will go into what? Ultimately, it will go as an electrical signal into the logic solver. The logic solver, based on the logic, it will determine and make some decision, and it will also give an output. By receiving the input from the sensor, the logic solver or the controller decides and sends out an output. The output will then be transmitted through electrical signal and then converted into whatever signal. It can be pressure, macam instrument air, or it can be solid noise, which is electrical signal. It will go to your finite element. The finite element will be the process control. It's much like you punya control bar atau you punya shut off bar. So that will be your finite element. Oh, sorry. Laura just now switch. Yes, consider a sensor because it depends on the application. So I'm looking at I think you were referring to loop oil backup near pressure switch. So that is considered as a sensor as well. So you have to understand that control loop, you only have three items. You have to have sensor, you have to have logic solver, and final element. So normally when things goes wrong, there's always probably people will say that logic is salah. So before we jump to the conclusion, you need to understand that what is in that loop particularly, and it will help you in troubleshooting better in better, because there's so many things going on when the system is running. So by isolating the loop, it gives you a better sight, a better line of sight, and also a clearer mind. So we move to monitoring function. So what's the purpose of it? So to identify early signal of engine failures, degradation, and also efficiency issue. So as what it says, is purely for monitoring. So we will have our local gauge or transmitter. So it will also have a display. You have a sensor. Sometimes you have a controller, sometimes you don't. But normally you will have a panel or display. And that display can be in the form of local gauge, can be in the form of LCD, which is like a transmitter, or it can be also wired to your DCS or your TCP as for monitoring. A very good example of in the gas turbine that is often used for monitoring is your P3 or your P30 if you use altitude level. So these are your pressure ratio, your compressor pressure, because we're not only looking at PCB. Sometimes we look at the 7 stage. Sometimes we look at most of it 7 stage pressure and also temperature. That will give us a monitoring. That particularly will not act as a control or even protection, but it serves as a monitoring to tell us how the axial compressor is operating. So common system is your BN3500, your system 1, your HMI, or your DCS is also part of your monitoring system. So how does DCS or panel HMI operates as a monitoring function? I won't throw a question. Without a HMI in your TCP, and your unit still run?
Yeah.
Yes, your unit still can run, even if your HMI blackout. Because that HMI is purely for monitoring and also user interface. The brain that is running the machine is actually in your control PLC, your logic solver. As long as your chassis still works, your card still works, without HMI, actually you still can run the unit. Okay, if you have solar, you will have dynamics. That is also one of your vibration protection system. So the objective for this protection function to work is so that we can treat the machine early before any catastrophic event happens. That is the sole purpose of protection function. So these are the few type of tripping function that we have. Machine trip. First thing is machine trip due to the trip coming from the machine itself. There's some deviation or some unwanted event on the machine. You also have your process trip to protect your machine. Example, air filter DP high. This is a process trip. Suction pressure high. Discharge temperature high. These are for your these are considered as process trip. And you also have non-machine related system protection process trip. That is, example, you punya ESD button being pushed by the operator at the control room, and that has nothing to do with the machine. It has nothing to do with the train, example the compression train or anything, but it's the process trip. So there's two types of process trip. One is directly related to the machine or the process. Another thing is related to the process but not related to the machine. Okay, any question before we move to the next activity? Okay. We'll move to a group exercise. Actually, I will show you a few keywords. under the function of monitoring, control, and protection, we have the purpose component as an example. So can anybody tell me what is visual assessment, alarms, and diagnostic belongs to? Belongs to which column? Belong to purpose, which column?
Monitoring.
Monitoring, correct. Okay, what about for process and equipment safety and integrity? Protection, correct. Control, optimization, and stability.
Oh.
This is okay, easy. We'll move to the component. We have gauges, transmitter, and it utilize PLC or DCS. Monitoring, correct. Tadi ada yo-yo sikit. Transmitter switches and then the signal goes to control element. The control. Correct. Transmitter switches that involve shutdown system. Okay, this one a bit tricky. Examples, transmitter switches involve shutdown system. System protection, okay.
It's the same.
Yeah. Ayo control. Okay, look oil pressure and inlet DP.
Monitoring.
Okay, control. Okay, fuel metering bulb opening and speed control. And last, look oil pressure, low trip, and overspeed protection.
Protection.
There you have it. You have this is the summary of what I just talked about for the past 30 minutes. Monitoring, control, and protection. So you have a basic grasp of what is actually machinery control is. It's split into three main categories. We want to monitor, we want to control, and last but not least, the most important thing is we want to protect machine. Okay, we will move on to so sebelum I move on to module 2, any question for first module?
Probably. So far so good.
Okay. If you have any question you want to discuss, you can just raise it up as well.
Sure.
It can be unrelated to the module that you want to ask about it. Okay, we'll move on to gas turbine component and auxiliary system. So what is a gas turbine? It's a typical internal combustion engine. So we have air drawn into the engine. You will come across to this term suck, squeeze, bang, blow. So we write it down. Suck, squeeze, bang, and then blow. This explains the operation of the working principle of a gas turbine. So first, suck. The air is drawn into the engine through the air inlet plenum. Or the first word, suck. We want to draw the air into the gas turbine as much as possible. So in the word squeeze too, it's through your compressor, the axial compressor over here. You will compress your air from atmospheric pressure to, depending on what model that you use, probably about 16 bar. Bang, you have your ignition in your combustor. The gas is expanded into hot gas. And blow, you use the energy from the hot gas to turn your turbine. And lastly, the remaining hot gas will escape through the exhaust. And gas turbine operation is based on Brayton cycle. Go back to your thermodynamics on this. Okay, let's watch a video of what is gas turbine.
Oh,
The plant. sound. Yeah. Let me down. Probably no more.
At Food Panda, we're on a mission to make life delicious. Cause some days the sun can feel like a lot.
Capitalism, right?
Two of the most common applications of gas turbines in modern industries are turbo generators and turbo compressors. I try to approach a gas turbo generator, or GTG, to better feel the subject. Before we get started on today's video, if you love our videos, be sure to click the like button below. Then make sure to click subscribe and the little bell to receive notifications of new Real Parts videos. This way, you never miss another one. In a gas turbine power plant, there's a generator, which is an electrical machine. But to generate electricity, this generator needs a prime mover, which, for my example, is a gas turbine. The gas turbine transforms the chemical energy in the fuel, for example natural gas or similar fuel, into mechanical energy. The mechanical energy generated by the turbine exit shaft is then transferred through a gearbox to the generator's shaft. Now, my generator can create electrical energy.
At Food Panda, we're on a mission to make life delicious. Cause some days the sun can feel like
This primitive form of electrical energy normally has a low or medium level of voltage, and to better manage the power loss in transmission lines, this voltage should be increased by step-up transformers. Such transformers give an adequate level of voltage to the electrical energy to be transmitted through the transmission lines and delivered to the grid. After this brief overview of a sample gas turbine application, I'm going to dig down into the gas turbine mechanism in more detail. First, imagine a rocket in which some fuel is going to burn and create a high-pressure exhaust gas. Based on energy conservation law, the chemical energy of the fuel is transformed into mechanical energy in the high-pressure exhaust gas. When a rocket is fired, the thrust of this exhaust gas moves the rocket forward. This amount of rocket science is enough for me. And now, suppose I fix the rocket body with a robust mechanical structure to prevent its movement. What will happen? The high-pressure exhaust gas should be released and it will have no way but backward. Now, keep this structure in mind and imagine I put a set of turbine blades in the path of this high-pressure backfired exhaust. You see that the release of mechanical energy, which is mostly in a linear backward direction, will mostly transform into a kind of rotational movement of the turbine shaft. And so far, I'd say it's a big success. In that, we've transformed the chemical energy of fuel gas into rotational mechanical energy of the turbine shaft. Now, I have a prime mover for my generator in the above power plant example. Also, this prime mover concept can be used in different applications like turbo compressors or the like. Now that I have the basics of gas turbines, let's focus on a modern gas turbine and its components. Most likely, you know about fire triangle or combustion triangle which illustrates the necessary ingredients of fire or combustion. In other words, fuel, air,
Thanks.
At Food Panda, we're on a mission to make life delicious. Cause some days the sun can feel like a wall.
and heat. To transform the chemical energy of the fuel gas into mechanical energy, the fuel should be burnt in the combustion chamber of a gas turbine. So I need air and heat added to the fuel. Air is let into the gas turbine through an air intake and mixed with a proper amount of natural gas. The air-gas ratio is determined based on the specific heating value of the gas and quality of the air, amount of moisture, altitude from sea level, and so on. Now, an ignition system steps in and makes the initial sparks, whereby heat is provided. When the fire is established and stabilized in the combustion chamber, the ignition system will be put out of service. The most critical process in normal turbine operation is to manage the combustion and produce a proper amount of high-pressure exhaust gas. This exhaust gas is applied to the turbine blades, and after rotating the turbine shaft, conducted to the exhaust stack. With this quick review of key components of a gas turbine, I think it's time to decrease the altitude and elaborate on the system further. As I mentioned earlier, air is let into the gas turbine through an air intake. The air is prone to contamination or having some unwanted particles which can harm the system and degrade the overall performance. The screening and filtration are basic requirements for incoming air. Also, proper instrumentation is mounted on the air duct to monitor the draft pressure and temperature. In harsh environments, the air might need to be preheated or conditioned. Also, differential pressure monitoring of air filters will warn the turbine operator of filter clogging. The conditioned air is conducted into the turbine air compressor, which is an axial compressor comprised of multi-stages of blades mounted radially on the turbine inlet shaft. The discharge pressure and temperature of the air compressor are monitored to manage the combustion quality at the combustion chamber. Fuel gas is a key factor in the design and operation of a gas turbine. The manufacturers need to know the details of fuel gas, and only based on its characteristics can they guarantee the performance of their gas turbines. Also, the pressure and temperature of fuel gas are monitored during normal operation of a gas turbine. There are different technologies in properly mixing the air and gas and making efficient combustion from manufacturer to manufacturer. Combustion chambers are of some tubular heat-resistant structures, and fuel is usually injected into it from the circumference and at different cross-sectional locations. The temperatures at different locations of the combustion chamber are thoroughly monitored by means of proper sensors like thermocouples. This high temperature, high pressure zone in a gas turbine structure is of the highest levels of importance to monitor and control. Also, the technologies used in the design and construction of the combustion chamber are of the topmost ones. Now that the air-gas mixing is well managed and combustion is going on properly, there is plenty of high-pressure, high-temperature exhaust gas generated and should be applied to the gas turbine blades to make turbine exit shaft rotation feasible. At this stage, the high RPM of the gas turbine rotor should be tightly monitored, and based on the load driven by the turbine, the surge of turbine gets the topmost importance for turbine performance and turbine protection. Vibrations, axial and radial, and speeds, both of the air compressor and gas turbine, should be continuously taken into consideration. This was the simplest way to address major parts of gas turbines, and as one of the most sophisticated man-made machines, a gas turbine deserves more elaboration. Also, there are different technologies which some manufacturers use as their proprietary technology, and were not considered in this video. Want to learn PLC programming in an easy-to-understand format and take your career to the next level? Head on over.
Okay, I think to summarize, the video shows that okay, just now the video shows you how a gas turbine works. Like I mentioned just now, sucks, freeze, bang, blow. And it tells you that how they draw the air and converting the chemical energy from the fuel into the mechanical energy. It uses the example of a rocket, pinning down a rocket and putting the exhaust gas or the hot gas through a rotational mode for you to turn whatever that you want, or most of the time generator or compressor, as you mentioned in the video. So now we are back to our commonly used gas turbine models. At your location, most probably you will come across these 4 types of gas turbines. You will have Rolls-Royce, or now we mention as Siemens. You will have Solar, and you will have GE General Electric. And General Electric, the frame 7 will be the industry. For the industry, heavy duty industry one, we don't normally see at our offshore location. Normally it's in downstream plant like MLNG. GE, I think Apik will have more experience on it after this. So these are the major section and component for gas turbine core. I split it up. On the top will be the industrial, and at the bottom will be the derivative GT. So anybody can tell me what is the difference between industrial and what is the difference? Why there's a difference of industrial and aeroderivative gas turbine? Compact. Which one is more compact? Okay, correct.
Robust.
Robust. Actually, which one is more robust?
Industrial.
Okay. Ingat, I thought you nak cakap aero dah. Nak tembak. Okay. We will have, but regardless whether is it industrial or aeroderivative, you will always have your intake section, where is your air inlet section. You will have your compression section, for you to compress the air. You will have your combustion section, and you will have your turbine section, and lastly your exhaust section. Just remember this, suck, squeeze, bang, blow. It's easier. Oh, we have a lot of auxiliary system in the gas turbine. There's too many of it. Generally, if I were to summarize it, you will always have your loop oil system, you will have your fuel system, you will have your air system, and you will have your starting system. These 4 normally that will give you problem lah, I can say. Normally you cover these 4 system, I think most probably you have already covered 80% of the problem. There are also some other auxiliary, example your ventilation, your enclosure, your control system, your base plate, your coupling, firefighting system, and water washing system as well. Okay, from industrial and aeroderivative gas turbine, what difference of system that you can see in aeroderivative but you cannot see in industrial?
Gear. Was it leaking?
Actually, the most difference is actually this synthetic oil, the mineral oil. For industrial, normally they use a loop oil. They commonly mention this as loop oil system. And most of the time, industrial they use mineral oil as well. So that oil can be shared between your driven also your driver. But for aerodynamic derivative, normally, typically your compressor is using a minerals oil system, but your GG or your gas turbine is using a synthetic oil. So it's two separate systems. Your pump also got different pump.
Why? Basically, they associate.
Okay.
Gas sensitive.
That is because nanti I think kita akan cover on why this aeroderivative is using synthetic oil. Okay, nanti I put down first. If it's not answered in the slide, then I will explain it. Or maybe we can get some of the participants to share their experience. Example. Okay, we move to we'll go section by section. We'll go from the intake section first. So the purpose of the intake section is to provide smooth airflow into the compressor. It consists of nose bullet, propel mouth, and also your VIGB, variable inlet guide vail. The purpose of variable inlet guide vail is also one of the most critical component in your gas turbines. It controls and regulates airflow going into your gas turbine, especially during starting up and shutting down. So we want to make sure that the compression is efficient and also to protect the turbine during starting up. We don't want during starting up, this VIGB is on a closed position. So when we say closed position, it doesn't mean that it's fully macam fire damper. It's kept at a very minimum opening degree. If you look at your what gas turbine model that you have at your location,
Mine is 750.
750. You open the enclosure, you go and look at the IGB or even your engine nameplate. Normally it will state there what is the opening degree. If I'm not mistaken, normally it's ranging from 5 to 12, maybe 8 degree at a fully closed position.
That's mean if VIGB when we talk about close, not totally 100% close.
It's not totally 100% closed. Unlike fire damper. Fire damper when it's closed, it's really close. No air can escape through.
We'll do that.
Okay, thank you, Mr. Emma.
Okay, this is the IGB angle versus your speed. But this is a sample from GE frame gas turbine. So you want to keep your IGB at the minimum angle is to prevent rotating stall. So what is rotating stall? It's a phenomena when you have too much air inside the gas turbine in your axial compressor, but you don't have the speed yet. The turbine doesn't spin so high enough to process or to move the air from stage to stage. So if you're at 100% NGP, you can fully open your IGB and allow maximum air inside, because just like we mentioned, the compressor is an axial compressor. As you spin faster, you can move the air from stage to stage faster. If your NGP doesn't establish, your speed doesn't establish, you will pack too much air inside, and the air cannot move to the next stage at the right time. So you will have a rotating stall. Means that the air stuck inside that particular stage or stuck in a particular spot and start to have turbulence instead of a smooth flow.
Cause the pressure.
It's some sort like that pressure where you are building up the pressure, example at stage number 6 or stage number 8, and then you can move to 9 and you will try to backfill. So the importance of this slide is talking about the IGB angle is correlated to your speed. Okay, so far any question? Intake.
How do we adjust the angle?
How do we adjust the angle? There you have to refer to your OEM manual. The one that is most commonly adjusted for solar unit, you need to have a special tool. It's a J hook or J. There's a special tool where you will. Sorry. There's a calibration block. J hook is the to move the linkage itself. So to adjust the linkage for the IGB, there's a calibration block that you can install at the top of the turbine, jumper block, and over there will be angle. So what you do is you fully close your IGB to hit that stopper, and then you lock that. You put it open to make sure that it's fully open also. There's a special calibration tool for particular model specific.
So different engine has different way to calibrate. Is the same concept? Is that tool different?
For angle itself, most of the time it's the same concept. If you recall your RB211, your RBDT is actually the one that is making the calibration. So you can something calibrate and look at the RBDT. RBDT is some sort of moving the measuring the angle also. If you tengok RBDT is always in degree kan, RBDT punya display.
What actuates the angle blade?
Okay, what actuates the angle blade? Most of the time, I can say 90% of it is actuated by hydraulic oil. So in solar, your loop oil will be your control oil. Same goes with your Siemens RB211, Siemens. The configuration is a bit different. For solar, normally it's very simple. You will just have a line of control oil and a line to release the oil to push. And also, but for Siemens, normally you have 2 RAM and 3 RAM. They call it 2 RAM IGB, 3 RAM IGB. So what does it says is only there is 2 or 3 different actuators at the ring. So if it's a 3 RAM punya IGB, you have 3 actuators located at 120 degrees apart. If it's 2 RAM, or sometimes they call low cost IGB, you only have 2 actuators. Normally they letak dekat 4 o'clock and 8 o'clock.
One
In a full circle.
not that different.
No, because Siemens RB211 normally is actuated one stage, whereas solar or GE you will have 5 stage, 5 IGB, 5 stage being actuated.
Thank you.
Thank you for the question. Okay, next we move to compressor section. So we move to the second one, which is squeeze. So in the axial compressor, you have your cage, your rotor, your stator. DSP we just cover already. You also have your there are 2 configurations for gas turbine: simple cycle or combined cycle configuration. The power plant nearby will be combined cycle. most gas turbine now design, I can say that it's prone for combined cycle because of the why they design combined cycle?
They don't want to waste the heat.
Correct. So it's to improve the efficiency of the gas turbine. So I think Apik has some experience with your WHIU, right? And Kasawari. Maybe you can share with the team of how does the WHIU and Kasawari works.
Okay, later.
Okay, later Apik can share what combine simple cycle configuration. Whatever that being combusted, exhaust gas being harvested by the turbine blade is directly ejected into the atmosphere. Whereas for combined cycle, this exhaust gas is going to waste heat recovery unit, or WHIU, waste heat recovery unit. So it's to extract the heat remaining in the exhaust gas, which is supposed to dump into the atmosphere anyway. So we use that heat to do something about it. Maybe we heat up the oil, maybe we heat up steam. In some downstream punya cases, they will heat up the steam. The purpose is to maximize the energy efficiency. Okay, we have covered the core section for the gas turbine. Before I move to auxiliary system, is there any question? Okay, so if you have any question, just stop me anytime. We'll move to the first auxiliary system, which is lubrication system. So in all rotating machinery, lubrication is the very important auxiliary system. We want to keep the machine operating with minimum friction. So we have to ensure that the lubrication system are working effectively. So we have a lot of monitoring, control, and even protection in the system. You can refer to API 614 that details out the lubrication system. The design lubrication system, what is needed, and how is it being designed. So a typical lubrication system will include a tank, a filter, a pump, a heat exchanger, and also some of the instrumentation. Okay, this is a typical lubrication system on an industrial gas turbine. Okay, so just now somebody asked about the synthetic oil. So I think we can cover here in under the lubrication for aeroderivative gas turbine. So we have two different types of lube oil for the whole gas turbine. We have mineral lube oil for our PT. Only PT we are using mineral lube oil together with the compressor. And whereas on your gas turbine, which is we call gas generator GG, is using synthetic oil. So why we use synthetic oil? That's not the question, because in this GG oil system, it is using a different type of bearing. It's using an anti-friction bearing for your aeroderivative gas turbine. So it is always, I don't know whether the other cover. Okay, I think I did not explain the why we use synthetic. It's because of in your bearing and lubrication, you know your normal bearing yang example your critical bearing, what kind of lubrication is using a hydrodynamic bearing. It's on a hydrodynamic lubrication. Am I correct? So mineral oil is sufficient for the usage of on application for hydrodynamic lubrication. What is the lubrication for anti-friction bearing? Anybody know? We always talk about hydrodynamic lubrication, right? But that is for normal general bearing lah. What about anti-friction bearing? Okay, so anti-friction bearing, you think of the ball bearing, example, I think ball bearing is so concentrated at that point of the circle of the ball. So in the process of rotating using the anti-friction bearing, the lubrication regime is actually undergo elastrohydrodynamic bearing, EHT, elastrohydrodynamic lubrication. So it's much more high on operating on higher pressure, it's also higher temperature at the concentrated point. So we will normally use synthetic oil for that, because it can withstand a higher shear and also to withstand a higher temperature. So you have your we always explain this only. This one is doesn't explain. Which I come across now. That's what happened. Okay, so boleh ya? So explain did I answer your question of why we use synthetic oil?
Yeah.
Okay, the GG oil or the aeroderivative gas turbine oil system, you have two. One is LP, low pressure. The is to provide the lubrication to the bearing, and we also have HP. HP is to provide the control oil to the IGB and also some other actuator. But in our case, our fuel valve, we are not using control oil, we're using electronic element. So if you come across with RB211, your GG loop oil pump, normally ada berapa stages? I'm not expecting Indra to answer. Akan Tony. Sukri tahu tak Sukri? You pernah buka kan? You have you to open? So normally
dia 5 side.
it's a stack. It's a vertical pump. So it has 5 stages. So two is for LP and sorry 3 is for one is for LP, one is for HP, another 3 is for scavenging. Okay, so that goes to I want to talk about scavenging first. Okay. So this is actually what I mentioned just now lah. You have your LP, you have your HP. L2, L3, L4, L2, L3, L4 is scavenging. So all these functions are done or carried out by single pump. You provide lubrication and you do the scavenging at the same time. Okay. Ada soalan on scavenging. What is scavenging?
Yeah.
Okay. You wanted to ask. I can see from your eyesight already. So what is scavenging? When you provide lubrication to the bearing housing, you don't want to overflow. You put a lot of fluid there, but you know for anti-friction bearing you cannot build up your lubrication level. You can have too much oil inside the bearing housing in short. So how do we ensure that there is always sufficient but not excessive oil inside the bearing housing? We use scavenging pump. What scavenging pump does is it suck out the oil from the bearing housing. As we are putting, we are also make sure that we suck out the heat up punya oil from the bearing housing, because we want to avoid the bearing housing being overburdened. Hi.
Why there are 3 the scavenging like that?
Okay, very good question. How many bearing you have in your RB2 level? Yes, so that's why you have 3 scavenging pump.
Okay, thank you sir.
Front, center and rear.
Yeah. So basically HP and LP to supply and then scavenging to suck out.
Correct. Correct.
Become one cycle lah.
HP is not supplier. HP is control oil. It's like I'm supplying the high pressure oil to actuate my VIGB. The LP is the one that actually supplying to all 3 bearing. And we have 3 different scavenging pump yang kat atas tu to start out from each different bearing housing.
Okay. Memang common lah 3.
Common for 3 because you have 3 bearing.
For Johnson.
Okay.
Johnson.
This is a typical HMI snapshot for the aeroderivative gas turbine for Siemens RB211. So you have your flow control valve, you have your scheduling valve, and you have your scavenging pumps. I think I've already explained scavenging pump. So what is flow control valve and what is scheduling valve? Nanti kasih speak. This is a scheduling valve. So anybody want to explain? Try explain what is scheduling. What is the purpose of? What is the function of scheduling valve? We talk about scheduling valve here. You have free wet, you have bypass, and you have schedule. 3 functions in this particular scheduling valve.
To see the oil flow to oil flow to bearing.
See the oil flow to bearing. Okay, partially correct. The purpose of scheduling valve is to make sure we have the correct amount of oil going into the bearing housing at different timing. Okay, this is flow control. Okay, I can use this also, flow control. You see here, at different speed, you will have different oil requirement. So on the x-axis is your speed, 0 to 7,000, and the y-axis is liter per minute. So you can see that from 0 to 2,200 RPM, you will need 1.5 liter per minute. In a normal starting up condition, you don't need oil at all when the turbine is not running, correct? So in that case, but you still need to test your lubrication system. Your lube oil will always start first to verify that all the system is working before I say, okay, go to crank the engine. In that time, the scheduling valve is operating on bypass. I run the pump, I don't want any oil to my bearing because my turbine is not spinning yet. It will go through bypass. And then, tadi kita nampak, during low speed, you only need 1.5 liter per minute. At that time, the scheduling valve will go to pre-wet to slowly turn up. Then after that, when you want to ramp up, it will go to schedule. You will switch to schedule and you will ask, how did they manage this? Correct? When your turbine is running 100%, scheduling valve is fully, memang scheduling valve is a three-way valve lah, I put it that way. So how do you achieve this gradient? It's through the flow control valve. There is another valve at the same line next to the scheduling valve to make sure you have your flow as according to your speed. And this is as equally important as your scheduling valve in your RB2 level. When you do what FU6 punya upgrade, B level kena buat. So we do a test we call bucket test. So bucket test is to make sure it is operating on this exactly the liter that we want. When I cranking, I want to make sure I get 1.5 liter per minute. I'm verifying that. And they normally sambut the oil with bucket lah. That's why they call bucket test. Because if you deviate from this graph, you can have lubrication starvation or you can overflow. Both are equally detrimental to your bearing. So I've covered control valve. I've also covered scheduling valve. Just now I mentioned bypass. So to direct that, when the JG is not running, you have pre-wet in your starting sequence below 2000 at 1.5 liter per minute, and you also have schedule.
Mean bypass the check flow.
Yeah. Before the system can say okay to crank, I want to make sure my lubrication is running. I need to make sure that when I run my loop pump under pressure, I don't want to say like okay lah crank lah. System go crank and then system initiate signal to run the loop pump. Bila tengok MCC contactor hilang. Actually, so it's not running but the wire will spin. So the sequence is always they will run the loop oil, GG loop oil, make sure the pressure due. Later we can see at one of the start sequences in the subsequent module.
Look at this during my BIF time. So the EIC for BIF shift. Very well versed on this.
Okay, we've discussed about scavenging pump as well. L2, L3, L4 is to suck up the remaining oil to make sure that you don't have excessive oil in the bearing housing.
Question
Yes.
For our info lah.
Okay.
Why the one industrial gas turbine we don't use any scavenging pump? Is it due to the nature of the bearing itself?
Correct.
Okay.
So you ask the question and you answer. Okay, why in
Maybe
industrial?
I need you to maybe to apa?
Like I mentioned, industrial gas turbine they're using hydrodynamic bearing. So in that case, you banyak oil pun dia tak kisah. You need the oil so that you can do the wedge.
Okay.
Of course, not like flood, but you will normally design the drain to be sufficient lah.
Alright, understand. Thank you, Sia.
Okay, we move to hydraulic and control oil. Just now we mentioned about this kan, HP linear line. It's part of the control oil or hydraulic oil. So in industrial, regardless it's industrial or aeroderivative, you have your hydraulic and control oil to actuate some of the actuator. So in some old punya facility or some units, you actually use hydraulic oil to actuate your fuel valve. The most common here you will see is your solar punya IGB is actuated by this control oil or hydraulic oil. But the new one all replaced by PECC in the front. Okay, we will have fuel system also. Fuel system, the function is to isolate the fuel, provide a constant fuel supply, provide a metered fuel flow. Okay, the important thing is metered. The fuel flow must be metered. Why metered? Why they specifically say metered, or why they specifically mention FMB in your fuel valve, fuel metering valve? Why is it? The meter, the word meter is inside.
Conversion. Conversion.
Correct. So that's correct. You want to meter because that piece of information is fed back into your controller to tell you how much opening you need. They convert the opening percentage of the FMB. Actually, they convert that into berapa fuel has been let into the combustion, and based on your gas punya composition, calculate what is the what they call that, the heat rate, so they can know it's they can heating value. They will calculate what is the heating value. So from there, they will determine that how much more gas they need to open, how much less gas they need to close. So it's all calculated. Dia bukan suka hati want to open or close and to go feedback. No, it's all calculated one. So I open at 30%. If you betul-betul observe your starting, especially at Center 50 VIF, you'll notice that during ignition, FNB open maybe 10% or 12%, and after opening dia akan tutup balik. If you notice that, after ignition dia akan stop. That is what we call stop-step. It will close back a little bit. That is to make sure that there is no overflow inside when the flame is already established. So how do they calculate that? They cannot rely on feedback loop. They cannot rely on control loop because it's too fast already, and any overshoot will bring damage to the turbine. So all these things are pre-calculated. So they say that okay, during first ignition I need to open 12%, and 12% equals to berapa cubic feet of gas that gives me this much energy. Okay, after I get the flame, how much more I need to step back, sub-step, so that I doesn't go into overfuel, I doesn't go into overcombustion. So these are all calculated. So that's why the word metered fuel flow is very important. Regardless it's in an industrial or it's in an aeroderivative, it is even more sensitive in the DLE engine. Yes.
For example, if there is a change in composition, gas composition, right? So the heating value will also change.
Correct.
So the value that inside the logic for this FMB will be predetermined, pre-calculated again.
Correct. Provided that you have updated your gas composition in the DCT controller. But in most of the cases, if you are not a DLE engine, this doesn't bring any. It doesn't bring much effect, I can say. It doesn't bring much effect because non-DLE engine is always operating on a very big margin that it will not easily go into flame out or overfill. It's sitting in a very, very comfortable zone. Any changes to the gas composition or heating value doesn't jeopardize the operation of the engine anyway. Yes.
Okay, I try to relate to the engine because the engine.
Louder.
I try to relate with the engine. Diesel engine or gas engine lah specifically.
Okay.
For the gas agency just now that Program mentioned, if have changed then turbine still run right. But for how we want to determine for example engine, if the fuel they calculate the gas analysis. Based on the gas analysis result, they will turn into the interface system. Then we come out with the maintain result, gas maintain result, which is will indicate the engine what you call can run efficiency 200 or less than that. So for turbine itself, how it determine?
Okay, so we don't calculate that. If you have been approached by CMD people, they are the one who tell you that you mentioned in engines, in receipt engine, that translates to efficiency, right? Same goes with gas turbine. If you did not adjust your gas combo properly, and it's always opening on a bigger, you are just wasting your fuel. So what we can calculate is actually the calculated and expected, actual and also calculated heat rate for that gas turbine. Let's say I take a very simple example. To run a generator, you will calculate, okay, what is the heat rate that is required to run this generator at 100% example. Let's say you need 30,000 kilojoule. Then that is your calculated at the most effective or efficiency, at the best efficiency. And you look back at your fuel, you have your metered fuel flow, right? Then you can calculate back, oh, my FMB open so much more. Actually, I'm using, my heat rate is actually 35,000. Oh, actually I'm wasting energy. So maybe you need to relook your gas composition. Maybe it's not so much on, it doesn't jeopardize the operation of the machine, but again, it goes back to efficiency, which directly goes back to your fuel wastage or your greenhouse gases in that case.
That one I calculate, right?
We can calculate.
So how about the parameter change? You can see obviously.
You will not see so much on the parameter change. Example, your T5, you will not see a very big difference. In fact, the fouling itself will give you bigger influence. So I want to say that a change in any operating parameter can be directly correspondent to your change in fuel gas, because it plays a very small role. Other external factors actually contribute to change of operating parameter so much. Okay, fuel system must be isolated. So I mentioned it's responsive. Fuel metering valve. Normally now fuel metering valve is all PECC driven, electronic driven. Intake system. Okay, I will skip a bit. Okay, is there anything that you guys want to stop me and ask? You can stop. Inlet, enclosure ventilation. Closure ventilation provide push end. Always run 1+1. If you no choice, you run 2. Okay, this is the cooling system for GE. So you use the compressed air to cool the turbine. Cool the engine itself. Sealing system. Sealing system through pretty cool. Hydraulic starting system. Okay. Anybody still using hydraulic starting system? Siapa? Semua lah. Tak, habis tu level memang hydraulic lah. Solar yang pakai hydraulic starting system. Tak lagi M1.
Oh, M1 persen lah.
M1 still using hydraulic starting system. Okay, this is your typical hydraulic starting system. You will have your charge pump. You will have a pilot pump, then with a charge pump, then to a main pump, which is a source pump. then you will feed to your hydraulic loop and eventually turn your start motor inside the engine. The starter motor will then turn the fuel shaft. There's a perpendicular shaft, and then eventually turn the engine itself. So the hydraulic oil never comes into contact with the engine. You also have a fire and gas system detection. Same also, this is also a control loop. You have your sensor, you have your PLC, which is your logic solver, and you have your final element. It's charge of catalyst, CO2. Okay, I think that concludes the module 2. So, is there any question before we go for a break? Okay, welcome back. Welcome back from your break. So, as usual, before after break, after break, let's do some energizer together. So I have prepared some true and false question. You can just answer what you think in your mind, and we see whether your answer is similar to the rest of the class. Okay, ready? Okay, before we do that, I always like to share. I would like to share a lot of graph with the training. It's a Dunning-Kruger effect. So the confidence level versus your competency. So when you know a little bit, you think you are very competent. As you know more, you feel like you are very not capable, but you will slowly as your competency improve. Okay. You can judge by yourself where you are at which level you are. You don't need to tell anyone. I hope everybody move to the right side. The two of sustainability. Okay, first question. There are two types of gas turbine: industrial and aerobative gas turbine. True or false? True. Okay, gas turbine runs on Brayton cycle. True. When IGB is closed, its blade angle is positioned at 0 degrees. False. Yes, it always has a minimum opening. Normal enclosure fan operation is one running and one on standby. True. There is no need to isolate fuel during unit shutdown, as the control system is sufficient to bring the unit to a complete stop.
False.
Okay, Flora answer false. Mr. Indra?
No.
Yeah, the answer is false. You still need to isolate the fuel. The three primary components of a standard gas turbine are compressor, combustor, and turbine.
False.
Primary. The three primary. True or false?
Yes.
True. Because some say the air intake is auxiliary. The pressure of the working fluid decreases as it passes through the combustor section. True or false?
Increase.
Yeah, so it's false. When you pass through combustor, you get ignited and you increase your pressure. A significant portion of the power developed by the turbine section is used to drive the compressor. True or false? Sorry, a significant portion of the power developed by the turbine section is used to drive the GG. True or false?
False.
False. Okay, the answer is true.
True.
Okay. Most of the power that's being generated is being used to drive back your GG. That's why you see a starter drop out speed or self-sustaining speed. The reason it's called self-sustaining because whatever that is produced is enough to sustain the compressor GG punya movement, GG punya rotation. And that is also why the efficiency of gas turbine is lower. Because you are using portion of the power to power back up your GG. Turbine inlet temperature is kept as low as possible to maximize thermal efficiency. True or false? Trick question.
It's a trick question.
So happy, true or false? You just start.
For
False. Johnson,
False?
you telling me or asking me?
other question. Asking.
Okay, the answer is false. Your turbine inlet temperature is to be kept as high as possible, but not exceeding the mechanical integrity of not exceeding the T5 lah, or T455. The one that kept as low as possible is the inlet temperature. Inlet temperature.
Oh, A lah.
Dalam 100 classroom ada. What was the range?
Sorry?
What's the range?
For turbine inlet temperature. Turbine inlet temperature normally after T5 lah. Lower than T5 a bit. Okay, last question. In a twin shaft gas turbine, the gas generator turbine is mechanically locked to the power turbine. Doesn't matter lah. In a gas turbine lah, I want to say in the gas.
Come on lah, Johnson. We've done this already.
Oh, serious ah?
No, false.
Okay, false. So for twin shaft gas turbine, the GG is aerodynamically coupled to the power turbine. Means it's not mechanically connected. So whatever the GG spin, the hot gas will turn the turbine based on the angle of attack. Okay, that concludes our energizer, and I hope that you are get back you punya energy lah for the next module. Okay, next module is gas turbine control and protection system. This is your starting permissive for a typical RB211 or Siemens SGT A35. If I remember correctly, without looking at it, there is 16 permissive you need to meet. Typical RB211. Let's count. I have to forget already. $17, $18. Okay, so yeah, so these are the starting permissive. What the starting permissive means that you need to fulfill the condition of what is stated at the text space before you can even push start. Before even it will allow you to start the engine. So example, your all alarm accepted. If you have not acknowledged and accept the alarm, it will not allow you to restart. Fire dampers open. So your fire dampers have the limit switch. If it detected your fire dampers are not open, it will not allow you to start the engine. So you will have to make sure that when operation tell you that I cannot start my engine, first thing first, you got to look at permissive. They fulfill all the permissive ketat. If they have not fulfilled the permissive, definitely you cannot start the engine. So that's always the first thing you need to go and see first when your operation tell you I cannot start the engine. Okay, then in one page you will also see the starting sequence. This is a very good pictorial or HMI representation of the starting sequence coming from the top to the bottom. It will give you what is the sequence by sequence of the gas turbine starting up and what is the timer that normally preset, or in that case, what is the timer being preset in this particular unit. It can be different from unit to unit. Whatever that you see here, buffer gas ready sequence progress 3600 seconds. It doesn't mean it's applicable for all units. Different unit has different watchdog timer. We call this watchdog timer, which means that for you to ready your seal gas and buffer gas, you have 3600 seconds. If within this 3600 seconds, you cannot fulfill this, starting the start of this abort.
But you can. Doesn't mean we need to play.
Doesn't mean if you fulfill the condition in 1000 or within 5 seconds, it will pass through and you will move to the next sequence. So when you are starting up, it's important to you to observe this, because whatever being stuck will tells you what went wrong, and you need to check that particular thing only. Otherwise, people call you and say, cannot start up, and you are completely blur. So by knowing the start sequence and which particular start sequence that it stops, it already helps you to drill down to the potential problem.
Must be accurate as these numbers ataupun dia ada range?
No, I think you don't need to monitor the watchdog at what particular watchdog it failed. You just need to know at which sequence it failed. Let's say from hydraulic example, okay, GG to purge speed sequence progress. Ada cakap fail dekat sini. Then you know lah. Maybe the GG didn't even crank. So you ask them, did the GG crank? Not sure. Cuba check starter motor. Oh, starter motor still record. Example. I have encountered that they say they cannot start. Fail to crank. Go check, belum read in. But they have not read in the starter motor. Commonly happen. Okay, this is typical gas turbine starting sequence chart. It's in the NGP or the speed, so it tells you what is the typical. So if I go through quickly, so you will ramp up once you have all your system check or your lubrication system, so you get system check, it will crank your engine. So you will crank up to 2,900 or 3,000. This is the purge cycle. It will purge off the excessive fuel remaining in your enclosure and in your engine. After that, you will go for ignition, and then you will go for engine pull away, and then you will go for your gas generator idle, and then once you are idle, normally you will stop for a while before you load. So you load, then it goes to full load lah. The second dotted line is referring to the IP spool, which is just now we mentioned the twin shaft kan. This is the HP shaft. This is the LP shaft, IP. And then the third one is referring to the PT, which is aerodynamically coupled.
IP is what?
Okay, just now we mentioned got twin shaft in a twin shaft gas turbine. IP is referring to intermediate pressure. HP is high pressure. Because this is an aeroderivative engine, there is also an LP, but the LP is the propeller outside that you normally see in an aeroplane, which we did not use in our application. If you see a propeller punya aeroplane, dia ada LP and propeller tu ada SLP. But in our application, it's twin shaft. They generally refer it as IP and also HP. Or they can say is NL or NH lah, speed, those low pressure speed or high pressure speed. Okay, any question before I move to control? This part maybe a bit tricky, so I try to be as simple or I try to summarize as much as possible for fuel control component. So you have so many sensors mounted on your GG and your BT, right? So what determines how much fuel is to be put in? All what we are doing in control is to measure how much we need to put into the fuel to control the speed up and speed down to maintain our process. Correct? So these are the parameters that they take into account to tell you that either you should put in more fuel or you should cut off something. Okay, so these are the typical. You have your speed control, you have your exhaust temperature control, and you have your maximum PCD. PCD stands for compressor discharge pressure, which is your actual compressor. There's a maximum pressure that you cannot exceed, and also it has a start control. So all these control, you have your parameters to feed in, right? Then you will tell it will go through all these LSS and HSS, low speed selector and high speed selector. So it's like a gate lah. Whatever, when I say LSS means whichever lowest punya value will pass through. So it will eventually determine you punya fuel valve, your fuel valve driver. And ultimate goal is to either to accelerate or to decelerate your gas turbine. Okay, we have temperature control also, apart from fuel control. Temperature control is to make sure that we are not firing our engine exceeding the allowable temperature that we can. There is a mechanical limit in the material that we have in gas turbine. Typically, if you recall properly, in your gas turbine, T5 high is normally around 1200, 1300 degrees C. So you cannot exceed that particular set point. So when you are at T5, you already hit your max T5. Max T5 is around 760 degrees Celsius for RB211. Same goes for solar, about 700, 760 and that. So if you are already hitting that temperature, what the turbine will do is it will goes to temperature control. What it means is I want to maintain the temperature at the maximum. Whatever you do, I will not put in additional fuel anymore. Which in that case, you are also unable to speed up your engine because it's trying to protect the engine. That's what T5 temperature control and T5 max T5 means. You cannot possibly go any higher anymore. We also have speed control. Speed control is the one that we normally being used. This is temperature control. Typically, it's T5 for solar, T48 for GE, and T455 for Siemens. Okay, so that we move to gas turbine protection. You have your 5 most common trip initiator. You need to remember. You have your overspeed, over temperature, flame out, combustion monitoring, and high vibration. These are the most 5 common trip indicator for the gas turbine. I'm not referring to the auxiliary. Whatever loop system, fuel gas system, those are your auxiliary or your process. So for gas turbine, these are the 5 most common trip indicators.
Flame out means no combustion.
Flame out means you lost the flame. Okay, when you are combusting in a combustor, spark plug. When you have fuel, or when you have air in, fuel in, and you have spark plug, you have the flame. You establish the flame. Flame out means that flame already extinguished. So what happened when the flame already extinguished? Whatever new fuel that coming in cannot ignite anymore, because you in your first ignition you need a spark plug, right? After that, if the flame, what happens if the flame already extinguished and you keep putting more fuel? So you have fuel, excessive fuel inside, right? That is not being burned, and if you did not eject it out properly during the next startup, it will be uncontrolled combustion. So it is a very important trip indicator. The moment I detect flame out, I need to trip the turbine right away. I want to avoid excessive fuel volume. Okay, auxiliary system failure also can trip the turbine, or any external system, anti-surge, generator protection, SIS. This is the common gas turbine protection punya chart. Overspeed, over temperature, loss of flame, rotor vibration, fire protection. Okay, fire and gas system. Fire and gas system is important for you to safeguard your recovery to recover your unit when you have any detection of fire gas. So what does it do is DT will shut down, enclosure fan will stop, your damper will be closed, and you will discharge your fire suppression system, either be CO2 or water mist. There are 2 types of shutdown, normal and emergency. If it's a normal shutdown, or sometimes they call pull stop. It's a control shutdown. You will unload, slowly bring down the speed, baru you akan close the fuel valve. So to reduce the thermal stress. But in emergency, you just cut off the fuel lah, because it's already an emergency. So if the situation allowed, normally we will try to go for a normal stop in a controlled manner.
For overspeed, for turbine itself lah, if we cut off the fuel and air or only fuel?
We will only cut off the fuel because it's not possible to cut off the air. What if you cut off the air?
If cut off the air,
and as the GG is rolling, because your GG cannot stop right away, cannot be 100 terus pergi zero kan? It will slowly, when you cut off the fuel, it's slowly from 100 go to zero, maybe within like 30 to 45 seconds, even in a very effective way. What if IGB goes to total zero? Because I know in engine you have the reservoir cut off the air. So, okay, what if you do that to gas turbine? Let's say you put in another flapper at the end, what will happen? What do you think will happen? It will goes down. That's the, yeah, the turbine is still spinning, you know. So you will damage straight away.
thank you.
Because for engine is enclosed, so you cut off the end. It's by the stroke. But for gas turbine, it's continuous. So that is the difference between both. Although both are ice, one is continuous, one is interval. Okay, now we move to our next activity, which is group discussion. I need you to break into 3 groups, so 2 people each. One team will take starting permissive, one team will take starting sequence, one team will take about trip signal initiation. So you can have 50 minutes to prepare, and I want you to summarize the gist of it. You can present, each team can have 5 minutes to present after you have prepared. Okay, so starting permissive, starting sequence, trip signal initiation. Okay?
Lagi.
Macam ni, 1, 2, 3. Okay, starting sequence, trip signal, starting permissive.
Apa ni?
Kalisihan satu deh.
Tu dah start.
Sen mau tolong dia langkah.
Permisi senang.
Sen cakap aku tak tahu. Okay, you want to use laptop present also can. You want to verbally present also can.
Yeah.
You want to use, but I want someone to present. You want to use the whiteboard also can.
Selalu pula ya.
Okay.
Tak, ni lah kita punya.
At least you can try to jot down lah. You want to verbally explain, right? Just jot down the points.
Okay, kamu ni dah. Say, apa to discuss, summarize, and present.
You can use this chart lah. You want to flash the chart, if you use the chart, then you can.
Yes, starting sequence.
Yes,
Kan
starting
lihat
sequence.
starting permissive.
Permisi senang.
Mesti lagi.
Starting permissive to
Trip signal initiation. Trip signal initiation will be the best over speed, over temperature. 5 minutes trip signal initiation.
Just a brief summary of it.
Yeah. Ada sedikit slide tadi ya.
All the 5 trips.
Ada 5.
Ada ni apa?
Bos sikit jadi bisa. Bos sikit.
Apa ya? Siapa jadi?
We just explain what this means.
Oh, kasar
You can
ni
use the
dia
board lah.
ada.
Write again, example.
Saya
Maybe 2 minutes to 5 minutes. Paling 2 minutes per minute.
Okay, on. Boleh contoh.
Kalau punya tapi permissive.
Ya, tadi.
Starting sequence is just this chart.
Rasa. Okay, right.
So this is what the first.
Just sikit je lah. For me, what I can do is
Untuk apa tadi kan?
just this is the
Starting
let me see. Then we apa dia?
18.
Berapa dia sebut? 19 18 lah. Ni kau just terangkan lah based on this apa. Kau jangan terangkan sikit. Kau tulis lah.
Terangkan sikit lah.
Saya sebut lah yang mana yang penting. Apa yang penting kau tu?
Untuk penis nanti.
Yeah, check lah alam semua dah. Dia dapat macam mana. Masa
Especially
gigi apa? Oil ball, smoking. Look. Mana?
Okay, sensor simplify.
Gigi untuk rolling.
pusing kan tukar.
Gigi rolling.
Dia lah start.
Asyik nyamuk dia asyik betul lah.
Explain. Oh iya ke? Jangan bergerak.
Jangan bergerak.
Kira-kira.
Dia asyik bergerak. Okey lah. Dia asyik bergerak. Okey lah, lepas tu
Kalau
saya itu sudah starter non apa artinya saya hidup lah.
kalau tu lah.
Yes lah. CGI soalan. Kita jangan kau kita semua kalau kita sendiri aja yang penting sekarang macam and then TCS so inside the TCS adalah kita engine control system so dalam tu kita nak apa lah
Yang tu di awal.
dia nak macam ni
Dia testing pusing tu.
ni
Kalau dia pusing
memang kita dah tahu ni bila semua asyik sebelah kita bagi cik konsep tu aku pasal tu dia PCS atau dia semua terangkan je kan dia bukan minta kau expensive dia and then pasal first orang cakap for every sequence dia ada yang pun watchdog yes so every ada lah yang pun what pasal orang ada what happen if what happened if when the permissive was checked by the timer artinya contohnya kau pun mesin lah dia tengah check lah tapi dia dah lepas the timer
Dia cancel.
Ida, you want to go first?
Yes.
Oh
no.
Yeah,
Sini.
you
Wah, Indra.
You want to use the screen? is it?
Yeah, we just
Okay, boleh. Ida will go
Okay.
first.
Johnson, you dah ready?
Okay. Use the one to explain. Use the paper.
Betul lagi.
Ambil satu yang aku saya. Oh, nampak.
Dia dengan casing.
okay, lagi jadi sikit ada stand
Yalah, kedengaran.
Aku belum.
Pak, bagi tahu dia tak lah.
kita nak cari umum pergi sih
Ambil video sekali.
One side of the day.
Tapi kalau risiko apa dia? Risiko kan risiko kan sudah dapat juga.
Tak lah.
dah lah saya dah lah
Waktunya set lah.
tu dia set dah kat City masih ada access nak like kan
Betul kan?
Rasa apa?
watch rasanya
Di sini pakai pattern.
ya lah dia pun mati juga kan ya
Okay, you guys ready?
Almost.
Okay. You guys ready? Okay.
Johnson ready?
I don't understand this chapter.
Dia pakai ni lah. Pakai secret. This one, ni is the secret. Apa yang tadi? This is the spring picture. So,
I think it's very good to this one.
Sini. From
From top to bottom.
briefly saja boleh.
oh nak lagi
But how do I know the station?
Kita bertanya. Kita sikit. Gila.
Tak sini.
Ah, ya.
Yang
Ah, ya. Dia just
pelita-pelita masuk.
saya belum. Apa dah lagi dah start. Tadi sikit tadi sikit. Apa dulu? Kan.
Kalau baru tu away je, baru start.
Bila kita start kita speed saya after few bila dia satu speed baru
Itu masih
itu masih
sama juga station.
Tak, sini je.
dia jadi sebenarnya kita
Ignition belum masuk mah.
trip
Ignition belum masuk.
contoh tadi apa yang
Tidak cepat. Baru just untuk
Ah.
sini satu away.
Pressure.
Sini project at this point.
silver lah
Pull away means
just ikut
Start dulu.
dah bersikit apa
From the
apa yang
combustion. Because the
dia
combustion thing start to okay.
Because of the speed, so you can see dia kan apa fuel.
means the engine will start to say
Slowly down. GGR. Grace.
kemudian
Kata tak?
Ini dia tadi stick. Bagus loh, this. Dia punya juga nanti asyik. Kau sama ni.
Okay.
Still ada kau ni. Ya, apa tu? Yang 451
bila
Lainnya tak?
dah. Kasih kira ini.
Yang penting lah yang
Dah dia release.
lagi kita
Alah, kurang lah aku, si kurang aku.
Asian Indian budgetary. Biarlah.
Kurang lah.
Ada lagi?
ada yang CP yang buat yang penting
Oh, untuk IC pun lah. Okay.
ikut aku ni
Ada aja sila panggil, dia dengar tengok yang apa.
SPM untuk perlu hari untuk mencari
Mungkin yang belum yang balik dah. Dia bawa balik semuanya.
Ready ah? Dah ready?
Dah. Dah ready.
You want to explain?
Okay. So who wants to go first?
me
Okay. You guys are ready? Boleh ya? Okay.
Can you use your slide?
Cabut lah punya kabel.
Okay.
Ang murong ko.
Okay. I think Indra you want to stand in front.
Nah, tengah ya.
Bukan.
yes
sini
Okay, my team,
Okay.
me and Afiq. So we represent explain about the start permissive lah. As you can know that every turbine before GG lah, before we start, we need to pass all the permissive before we can go to the starting sequence lah. Alright. So for example, this one is for RB211. So there is 18 permissive that we need to pass. Okay. If you can see, the permissive is at left side. So there is 18. Which what part yang you need to pass. And then I explain the display first and then you can see at the right side is the actual and present, the watchdog timer. So basically the present is the limit setting lah. So you can exceed the timer. If let's say the sequence, for example, no shutdown, GG not rolling, it's set 6 seconds. Okay, GG roll down, it's set 480 seconds. So before at 180 seconds, you need to pass the sequence. If not, it will reset again, and you need to check first After that, you try again. So basically, the actual is whenever your sequence finish at what time lah, basically for your own record. For example, like 480 seconds is the setting. Might probably you 200, you already pass. That's the it lah. So all 18 you need to pass, and then you go to start sequence. Okay, anything? Check. No? Alright.
Okay, thank you Indra and Afiq. Okay, next, Johnson and Glow, is it? Okay. Okay, Johnson.
Okay, next is about starting sequence out. So from this we can see that there is 22 starting sequence that the GG or GT has to follow. Sorry, for the gas generator to follow lah before it is fully started. And we have to make and similar to the starting permissive just now, we have to achieve the required parameters during the starting sequence timing to proceed to another step. Yeah, if the timing is not achieved, then there might be some problem, and you have to check over there. Yeah, so this is the starting sequence. Yeah.
But not all is timer related lah. Example, ignition, that is not timer related lah. So some is timer related, but some is not. Example, scheduling, flow control panel, lubrication to that one is not time related. Scheduling valve is not time related. So you have to be careful lah, because not all things are displayed all time related. So you need to be able to know that what exactly and what sequence that is stopped.
Alright, thank you CF.
Okay, thank you Johnson. Next we have Fanny and Effie.
Okay, good morning, everyone. Today, me and Effie will explain a bit about the trip signal initiation. So why gas turbine needs protection is because we want to minimize any potential unwanted failure. Doesn't matter electronically or mechanically. So there are 5 trips that is very important for gas turbine. So my friend here will explain briefly about those 5 trips.
These are 5 indications related to the GT protection. The first one is overspeed. The bike is spinning a little too fast. And the second one is over temperature. Then third one is flame out. In the very inside the engine is goes out. And the fourth one is combustion monitor. And the last one is high vibration. That is the 5 trip indication. Thank you.
Okay, thank you. Okay, what can you conclude? What is your takeaway from this group presentation? What's your any takeaway from this presentation? The presentation group activity.
I think probably
It feels easy, right? When
Yeah,
I'm
yeah.
the one explaining it, but when I ask you to explain it, it doesn't look so easy anymore.
yeah.
So the details, that's why I want you to understand that whenever that you can explain to somebody, that means you really understand the topic very well. So one way to practice or to gauge whether your understanding is enough or not is you try to explain to other people. If you can explain to other people, more often or not, you have already understand the topic. And also through explaining to other people, you gauge where is the gap, where is your knowledge gap, and through all the questions and answer. Some of the questions that you give me maybe makes me reflect also, oh maybe this part I'm not well prepared yet, so I need to go and find out more answer. So that's the purpose of why, even though I've just gone through the material, but when I ask you to do the presentation, still there's some hiccups, right? So practice to explain. That's my key takeaway.
Okay, that's it.
Okay, we'll come to the end. I want to ask, is there any other question that you want to ask? Yes.
The relation of a voting system with monitoring production.
Okay, voting system goes back to your, if you are talking voting system or process, it goes back to your IPF, instrument protection function. So, of course, you put voting system, you need to put more sensor, am I right? So there's additional cost, but it gives you robustness and also flexibility. Example, if you have speed probe, normally speed probe we have spare, and we have voting 2 out of 3. Because it is a critical element that we need to make sure that it doesn't fail or give the wrong signal. But for things like, example, if you ask me, look what header temperature, why we could have put 2, right? So that when pressure transmitter hit 40, we still can save the unit from tripping. But it goes back to the cost and how frequent this thing happen. If it's and it gets 40, does it need to catastrophic event? It doesn't, right? It will still trip the unit. So it goes back to your cost analysis and also your ITF, how critical or how impactful that failure will be. Kena tiga balik tu.
Voting system is still related to protection.
It is related to protection. It is related to protection. Okay. So no other question. I would like you to go through the post test. Pas kat belakang.
Dan sama you Hey, you don't remember what the answer.
That is the fun part.
What is dia lagi keluar?
Ya. Tu dah kutip.
I put his sound in.
No. Sorry. Itulah pakai answer ni tak. Sila, question mark please. See what the
Okay. All that.
nama. Kok nama?
How about you keep the post test first?
Huh?
You keep the post test.
Keep.
Then we can we will go through together.
Oh. Yes. Apa dia tak boleh?
Nah lah, we will go through together.
Yes.
We will for Johnson for what? No worry. Okay. Alright. We will go through the post test together. So question 1. The purpose of protection function is to prevent escalation of harmonic. Okay, that's easy, right? Question 2. These are the process parameter that can be controlled except
B.
Operator's response time, betul.
Yes.
Number 3, what is the primary thermodynamic purpose of compressor section in the gas turbine?
C.
D.
To increase the
Static pressure.
Correct, to increase the static
Oh.
pressure density.
Betul tak?
D. Number 4, which of the following describe a localized non-destructive aerodynamic disruption where a small zone of store air rotates around the circumference of an axial compressor rotor?
B.
Rotating store. Betul, tadi kita mention rotating store, right? What is the primary function of a turning gear or bearing gear?
A.
Yes, the answer is A, to slowly rotate the shaft to ensure even cooling and prevent thermal bowing of the shaft. Number 6, which parameter is modulated by the primary acceleration control loop during the initial ramp up?
C.
D.
Oh, banyak soalan kan? Initial start ramp. The answer is
D.
D, the rate of change of fuel flow. Salah baca. Baca 2 kali pun boleh salah.
Cari jawapan yang pendek.
Okay, under what condition will your EGT limiting control loop override the speed control?
C.
C, correct. When the measure EGT reach or exceed the maximum safe operating limit. Okay, number 8. What's the primary operational hazard if fail to ignite?
D.
D, betul. Tapi kita dah ceritakan. We already mentioned it. Okay, number 9. How does a DLE combustion control system achieve lower emission without utilizing water or steam injection?
D.
Correct, C, by thoroughly pre-mixing. Okay, DLE punya operation is they are pre-mix dulu, mix the air and fuel so that it's on the most lean punya ratio for the lower NOx emission. NOx as in NOx, nitro oxide. Because nitro oxide will be developed during high temperature combustion. Okay, last question. Which component in the gas turbine protection loop serves as the final mechanical interface to block fuel flow during emergency creep?
B.
B. Fast acting. The key is fast acting. And it's emergency fuel shut off valve. Okay. I hope you improve and get more clarity as compared to the pre-test.
Yeah.
Some will actually cover in the class. Okay. That's for the post-test. Okay, we'll lastly do a recap on learning outcomes. So we've gone through the training session. So by the end of the training session, let's see if we have achieved the recap. So you can explain and differentiate the concept of machinery monitoring, control, and protection. Yes. Yes, you know the difference between monitoring, control, and protection.
Yeah.
Number 2, you can describe the operating principle. Major components in the subsystem of the gas turbine. Yes.
Yes.
Yes. And also the principle, suck, squeeze, bang, blow. And the subsystem, you know some of the lubrication, you know the fuel flow, you know the hydraulic system. Yes, all the auxiliaries. Number 3, explain the startup permissive and sequence of a gas turbine. Okay. Right.
Yes.
Number 4, you understand the protection system on the gas turbine.
Yes.
Okay, there are 5 major trick initiator. Okay, I think the learning outcome is achieved. So last but not least, I need you to help me to fill up the evaluation form. Ni. Tak perlu tak.
Dia lagi pan dia jangan lagi.
Dah, kau faham tak? Tadi ini tak pin tu deh.
Oh, ada dengar.
Lepas slow.
Tak.
Okay, thank you for filling up the evaluation and you can pass me back the evaluation form after you have completed.